In order to solve for x here, I'm going to take the e of both sides, meaning I put it up in the exponent. So e to the ln of x gives me x, and e to the -1 is a number. I can think of it as 1 over e, or I can leave it like this. Do not use your calculator. That's just a fine answer. Here I'm going to divide through by the 2 first. So I get equal to 5. Now I'm going to take the ln of both sides in order to get rid of the e. So moving over here, so I'd have ln of e to the 2x plus 1 equals ln of 5. The ln and the e cancel, so I get 2x plus 1. ln of 5 is a number, so just leave it like that. And then so solving for x, I'd get 2x is equal to ln of 5 minus 1. X is equal to 1/2 ln of 5 minus 1/2. Okay, here we have ln. I get rid of the ln by taking the inverse of which is the e. So this e and ln cancel, so I get 2 plus x is equal to e to the e power. That's both numbers. So then x is equal to e to the e minus 2. I see exponents here. I notice there's things in common. So let's factor out an e to the 2x. You remember that e to the 2x times e to the 2x is e to the 4x, correct? We add exponents. So e to the 2x minus 2. So now I have two factors, setting them both equal to 0. So I get e to the 2x is 0, and then e to the 2x minus 2 is 0. E to the 2x is never 0. There's no number that we can take to the exponent to make it 0, so there's nothing from there. So e to the 2x is equal to 2. Now to solve for the x, I'm going to take the ln of both sides. ln of 2, so this ln and e cancel, so I get 2x is ln of 2, so x is equal to 1/2 ln of 2. Oh my goodness, look at this. So let's take the ln of both sides first. So ln of 1, I want you to know ln of 1 is equal to 0. This here, this ln and e cancel out, so I'm left with e to the x minus 1 equals 0. So this turns into e to the x is 1. Now let's take the ln of both sides, and I get x is equal to ln of 1 or 0. Ooh, 3 terms. We know what to do with 3 terms, right? We see that as the quadratic. So it's a quadratic in e to the x's. The other day we put a quadratics in sines or cosines. So I'm going to get a minus 3 and a plus 2. So e to the x is 3. E to the x is negative 2. So this gives me no solution. So whether you think of the graph or you know that you cannot take the ln of both sides, this gives me no information. This one here, I'm going to take the ln of both sides, and I get x is equal to ln of 3. So e to the x, looks like this, right? There is no way we can get a negative number out of this. Okay, so what are we going to do with this one? So I see a negative exponent here and not here. So let's just start off by writing the negative exponent in the denominator. Then, how about we multiply both sides by e to the x? Multiply both sides by e to the x. So this gives me e to the 2x minus 12 minus e to the x equals 0. So distributing that out. And again, if I take the time to rewrite it, I can see it's a quadratic in e to the x's. So I have minus 4 plus 3. So e to the x is 4. E to the x is negative 3. No solution from that. So here I get x is equal to ln of 4. Okay, you never want to divide through by a variable, so you want to first get this equal to 0. Then I can factor out an e to the 3x, and that's going to be e to the 3x because I add these to get e to the 6x minus 4. So from here, I get e to the 3x is 0, or e to the 3x minus 4 is 0. So from here, I can take the ln of both sides and finish off by dividing by 3. This one, no solution. Oh my goodness, look at all of these big ugly letters. Okay, so P, Q, and R are just constants. So this one, I'm going to get the e's, since I can't see how to factor anything out like this one up here. I had factoring going on. This one I'm going to divide. So I have e to the px divided by e to the qx is equal to r. Now I know this side I could rewrite as e to the px minus qx. Oh, I know. How about now I take the ln of both sides? So if I take the ln, e and ln cancel. So I get px minus qx is equal to ln of r. Now let's factor an x out. P minus q. And so then x is equal to ln of r over p minus q.